My name is Brian Chess. I'm one of the founders and chief scientist at Fortify Software. And thanks for taking time out of your siesta this afternoon to talk to us about software security implications of the cloud. Jacob, you want to introduce yourself? Because you're director of...
Yeah, I'm Jacob West. I'm director of security research, also at Fortify Software.
All right. So I want to start by talking about my favorite software security book. It's Petrosky's To Engineer is Human. And it's not about software, and it's not about security. It's about how do you build stuff? And how do you build stuff so that it doesn't blow up or fall down? And he says success is foreseeing failure. And I think that's a perfect message for anybody doing security and digital security in particular. If you want to build something that's not going to fall apart or blow up, you have to be able to predict how you're likely to fail. That's particularly interesting when we start talking about something like cloud, where it's not obvious, because we haven't been doing it for a really long time, it's not obvious what the failure models ought to be. So let me give you 4 of them. 4 of them that I hear people talking about. We're going to spend all of our time on the last one. But I think it's worth going down the list, at least to put a little bit of room between these. Some of them Hoff mentioned this morning. Same old, I think is the first one. And that is, if your biggest security problem is that Charlie Miller doesn't like you, probably your biggest security problem in the cloud is that Charlie Miller doesn't like you, right? So if you've got a particular kind of defect that haunts you, if it's cross-site scripting, if it's buffer overflows, probably it's going to haunt you in the cloud too. Okay. But the world would be a pretty boring place if what we were saying is that cloud doesn't change anything. Cloud does change things. So let's talk about some of the things that it might change. I think particularly a lot of the black hat mentality is looking for the one bug to rule them all. Whether that's a bug in the hypervisor or the way the CPU caches memory that's going to allow you to crack keys. One bug that's just going to flatten the whole landscape. My experience, and you can ask Dan Kaminsky, I think he would probably agree, that the one bug to rule them all doesn't last that long. Either everybody patches, or everybody figures out how to live with it. The much more interesting bugs are the ones that separate you from the herd somehow. The one that probably gets the most airtime when we talk about cloud is the relationship fumble. And that is the people who are providing the cloud and the people who are utilizing the cloud aren't the same anymore. They don't have the same logo on their name badges. And therefore, they maybe don't have the same ideas about what's important. Probably they don't have the same ideas about what the security policy is supposed to be. And they certainly don't have the same people writing their paychecks. Actually, I think this is going to turn out to be one of the greatest strengths of cloud security. Because the differences between these interests and the relationships between them are made explicit by the cloud. And so we're going to get better at writing contracts and getting explicit about what expectations are. So I like that one, but I like the last one more. And that is, we're going to take some code that was running happily somewhere. It's not necessarily perfect, but it's running happily. Put it in the cloud, and all of a sudden be exposed to new risks. And that's what most of this talk is about, is what kinds of new risks do you get exposed to when you move code into the cloud. First, I want to talk a little bit about why move code into the cloud. Why is this a migration exercise? So you can pick your favorite analyst and go get their numbers. Gartner's giddy about the cloud, so I took their numbers. They think that the market's going to grow at about 16% for the foreseeable future, which is exponential growth. So that goes from around $70 billion today to about $150 billion less than 5 years from now. That's a quick clip. The truth of the matter is we can't write code fast enough to justify that kind of growth. So instead of writing code, we're going to have to take code out of one context and move it into another context. This idea that you can just rewrite for the cloud isn't going to meet the scaling that we're looking at. So either the scaling isn't going to happen, or the code is going to move. Having sat there in college and watched people project the growth of the internet, the number of hosts on the internet, and they get to this point about 1998 where there's like, okay, well everybody is going to have a computer that's attached to the internet. And at the time, that was kind of unthinkable. Like, how is everybody going to have a computer that's attached to the internet? Well, we figured it out, and everybody has a computer attached to the internet if they have only one. So I tend to think that the technology challenge here is actually the one that's going to give, and that we're going to move code into the cloud. But even if you don't buy that, even if you think we're going to write code for the cloud, and that's what's going to account for the bulk of this cloud adoption, we're going to have to reuse a different component, and that is the programmers. We're going to have programmers who are used to building outside of a cloud model, building for a cloud model, which means, by and large, they're going to write the same kind of code they know how to write, only now they're going to put it in the cloud. That means we've got to talk about this migration concern. So we're talking about code that was built under one set of assumptions that's going to execute under another set of assumptions. Now, you just wouldn't be a very good security professional if that didn't say, aha, I'm going to revisit the threat model. That's pretty clear. What we want to say is, after you revisit that threat model, the next thing you're going to have to do is revisit the code. And we're going to talk about specific examples of where that's going to have to happen. So, Jacob, I'm going to hand it over to you for that.
All right, thanks, Brian. So I'm going to talk about 4 areas where code that's being migrated into the cloud needs to be revisited or thought about in somewhat of a different way, where the risks are going to change. These kind of tier on top of each other. So they start from a broad level of a loss of control of the network topography. So you don't get to put hardware on the network. You don't get to control the network segments necessarily. And that has a lot of implications on the way software is going to behave. Then I'm going to talk about 2 topics related to data. So I want to kind of classify data into 2 broad classes. Data that is application data. So the stuff you're writing into your database, the stuff you're operating on, the stuff you're taking from your users, giving back to your users. And then I'm going to talk about collateral data, log entries, things that you aren't really thinking of as primary to the application, but are being generated and in some cases kind of sprayed out from the application itself. And both of these types of data are at risk in new and more intense ways in the cloud, both in transit and at rest. And we'll talk about some examples of those. And then finally, I want to talk about how all of these factors combine to make code agility, the ability to update, patch, fix code from a security standpoint even more important in the cloud than it was before. So first off, network topology doesn't hold still when you move into the cloud. As I said, you lose a lot of control over the infrastructure and the makeup of the network. You don't have those nice enterprise firewall ingress or egress rules anymore. And you can't rely on network routing mechanisms in the same way that you could before. This increases the risk felt from things like unencrypted communication, hard-coded IP addresses, and resolving host names. So first off, some simple examples about the firewall, right? You've got internal data center. You've got a nice enterprise firewall around it. That does the obvious thing, which keeps attackers from being able to attack unencrypted communication channels. So if your app is talking to your database over TCP, that's probably OK, no big deal. But it also limits the number of those unencrypted communication channels you might have, because you can ensure that no matter what your programmers try to do, they're not communicating with external systems outside the internal data center over any sort of channel, encrypted or otherwise. Now, moving into the cloud, you lose the obvious protection of the firewall, and that's an important one, but not the be-all, end-all. But more importantly, you don't know who your application is talking to anymore. Your programmers might decide that they want to rely on some third-party external resource that lives not only outside your internal data center, but outside the cloud provider as well. And now the communication channel that they talk to that external resource over becomes a lot more important because it's more susceptible to man-in-the-middle style attacks. Another problem is hostname resolution. So in the internal data center, you own the primary application, you own the external resource, the database, or whoever you're trying to resolve the host to, and you own the DNS server. So although it's possible for that DNS server to be compromised, you have some reasonable confidence that at least it's under your control. It's a resource that's not being shared with other folks. Now, in the cloud, you're relying on somebody else's DNS server, which increases the chances that someone is going to compromise it, attack it, or inadvertently cause it to misdirect traffic from a host that you expect to be friendly to you to a host that's malicious. And this is dangerous both for incoming data, resources that you're relying on, and outbound communication, in particular some of the collateral data that I'll talk about later. Okay, data storage and access. Everybody gets that protecting data is an important aspect of migrating to the cloud, because suddenly you're taking data that used to live on your server and your hard drive and putting it on a server that's not under your control. So things like whole database encryption are a popular solution to this. We don't want to worry about what happens to those hard drives when we cancel our contract with that cloud provider and move somewhere else. So we're going to encrypt the whole database. But inadvertently, applications may undermine the security of data in transit by communicating over unencrypted channels. So things like this, JDBC connections over unencrypted channels, that might have slipped under the radar as relatively low priority findings in a security review of the code before it moved outside of the internal data center, suddenly take on a new significance. And maybe a few years ago you had an argument about, well, is it okay for this server to talk to that database over this channel? And maybe it was, maybe it wasn't. Some developer made a strong argument for why it was. Did you write down all those decisions and why at the time you decided it was okay? When you move to the cloud, are you going to know to revisit all of those decisions? So this is the first example of where it's important to come back to the code and consider, were the decisions that I made when it was living in an internal data center, something completely under my control, wise ones? And do they still apply in this new environment and new landscape? Collateral data. So let me first talk about what I mean by collateral data. Everything that isn't core to the application functionality. So log entries are a good example. Debug information. Anything that you're writing other than sort of what you think of as the primary functionality of the application. The risk here is that it might expose information about the way your application behaves. So debug log entries let an attacker profile your application, understand what versions of particular infrastructure you're using, open source libraries, and so on. But it might also contain private information, sensitive user information, things that are important to protect. And while everyone moving to the cloud is focused on that core application data, so we're going to encrypt our entire database, are they thinking the same way about storage of collateral data, log files, and so on? Again, these can be exposed both on disk at rest and in transit. And this is primarily caused by those same communication channel issues and data storage issues that we talked about in the first 2 points. So something goes wrong with your application. And in the old model, developer says, OK, well, I need a log file. And I don't just need any log file. I need you to turn on debug logging. Give me all the gory details because I need to figure it out. And in the old world, that was probably not the best advice, but you could get by with it for a little while because your network topology limited how far that information was going to spread away from the application. Probably it was written to the local server, maybe to an external log server. Either way, it was inside your data center, and you had some pretty solid constraints on how far away, how widespread it could be. In the cloud world, because of the first 2 points we made, you have very little control over that. You have very little ability to ensure that that debug information that's going to let an attacker do more damage to your application isn't going far afield. So again, small warnings that might have come up in a code review or a review of your configuration security that maybe a few years ago in your internal data center you said, this isn't a big deal, we can live with it at least for a short period of time, now become much more serious. You guys heard about the problem Blippy had, right? This is a little startup that analyzes your credit card transactions. And during their beta period, they took all those credit card transactions that they were going to keep super secure and wrote them out somewhere that got indexed by Google. So all of a sudden, if you were a Blippy user, you could go search on Google and find all of your credit card transactions. This is a great example of they didn't know where that information was going. And it happened to be that they wrote it out to a place that Google was getting access to. And that certainly wasn't their intent. But in a cloud environment, you lose those physical constraints on where data is going and how it's protected. So focus not only on the core application data, but also on the collateral data, the things that you might not think about needing to be encrypted when they're sitting on the same server as the application inside your data center. But now, who knows who has access to them? I'll give you another example about code agility. So Twitter started out as this little social networking company. Only people in the Bay Area had ever heard of them. And their market risk was really high, right? They took some investor funding. They made this company. Nobody knew about them. They probably were going to fail. And all of a sudden, people started to learn who they were. And their market risk went down. And what happened to their security risk? Their security risk started to go up because it started to have some value. People knew who Twitter was. People were using it. Maybe not relied on it, but certainly would have been pissed off if they didn't have access to their tweets in the morning. Twitter had some security problems over the last couple of years. You guys heard about these, right? One in particular was their admin interface didn't throttle password login attempts. So you could brute force it very easily because you could just keep trying forever. And their code admittedly was fragile.